Hello guys, welcome back to my YouTube channel. So today we are going to solve day 24 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today we are going to solve problem number 951, flip equivalent binary trees. So actually this problem is very easy. Okay, so this is a simple recursion problem. Okay, so let's read the problem statement first. So for a binary tree T, we can define a flip operation as follows. We have to choose any node and swap the left and right child subtrees. A binary tree X is flip equivalent to binary tree Y if and only if we can make X equal to Y after some number of flip operations. We are given the root of two binary trees, root 1 and root 2. We have to return true if the two trees are flip equivalent or false otherwise. Okay, so first see this example number 2 here. Root 1 is null and root 2 is null, so that is why simply we are returning true here. Okay, so these two trees are equal, right? Two binaries are equal, right? So this is one base condition. So let's write the code for this one. Okay, this base condition. So here in my code, let me just zoom it. So let's write the first this base condition. If my root 1 is equal to null and my root 2 is equal to null, okay, both are equivalent, right? So in that case simply return true. Okay, so this is one base condition, right? And this is a boolean method given to us, right? Flip equivalent boolean. Okay, and here see this example number 3. Root 1 is null, root 2 is not null here, right? And there is one value. Okay, but you see that we are returning false here because these two binary trees are not equal. Okay, so this one tree is null. Okay, there is nothing, and in this there is one, so these two trees we can't make equivalent, right? So that is why we are returning false here. So let's write one more base condition here. If my, let's say, root 1 is equal to null, okay, or if my root 2 is equal to null, okay, root 2 is equal to null, okay, or my root 1 dot val, root 1 dot val is not equal to root 2 dot val, then in that case simply return false. Okay, so what I'm doing here, I'm checking if any of these two trees root is null, and then after it I check if the values are not matching. Okay, so in that case we have to simply return false. Okay, so two base conditions I have written here. Okay, if both the roots are null, then simply return true, and if any root is null, and then I check for the values. Okay, so if values are not matching, so simply return false. Okay, that's it. And now let's move to the example number 1. Okay, so first example, so these two are the base conditions. Okay, so now how what we need to do here. Okay, so and how we are going to do it, let's see. So two trees given to us, this is tree 1 and this is tree 2. Okay, so initially you see here, this is one matching. So let's proceed further. So here this is my root initially, right? And this is my root, so this is nothing but my root 1 and this is nothing but my root 2. Okay, so here I am going to check if root 1 dot left is matching with my root 2 dot left. So here it is clear that both are not matching, right? We have just flipped it. Okay, so here let's do one thing. Instead of comparing here, instead of comparing my root 1 dot left with the root 2 dot left, let's do one thing. Let's compare my root 1 dot left with the root 2 dot right. Okay, let's do this. Okay, so simply means that maybe we have flipped it. Okay, let's say we have flipped it. So here you see 2 is on the left of 1 and here 2 is on the right of 1. Okay, so I am following this path, right? This path now. Okay, so here 1 and 2, 1 and 2. Okay, now for this 2, let's see the left and right. So here 2's left and 2's right in both sides are matching. Okay, so we are good. Okay, so now let's say I reach to this 4 left and 4 right both are null, and both are matching in all the positions, so we are good. Now let's check 5. Okay, so 2 is 5, so here we did one flip. Okay, here let's say we did one flip. Okay, that is why we are comparing this left with the here it's rights. Okay, so now here I move to this 5. Okay, so now here for this 5 you see that uh, 5's left is 7 and here 5's right is 7. Okay, so here it simply means that again we did some flip. Okay, again we did some flip operation, that is why 5's left is matching with 5's right. Okay, here right, what I'm saying, 5's left is matching with 5's right and 5's right in tree 1 is matching with 5's left in tree 2, right? So here overall you see that this side, okay, this side is matching with this side. Okay, so r1 dot left, r1 dot left, okay, this r1 dot left and here r2 dot right, r2 dot right, they are matching, right? They are matching, right? R1 dot left is matching with R2 dot right, this complete. Okay, so if this is matching, then there is one more thing that I need to check. Okay, so here AND operation, what I need to check, so if R1 dot left is matching with R2 dot right, so I have to compare then R1 dot right with R2 dot left, right? So this is a basic thing, right? R2 dot left, so let's do that. So r1 dot right, if I go to r1 dot right I see 3 and r2 dot left I see 3. Okay, all right, now for 3 we need to check children. So here see this is null here and here it is null, so definitely we did some flip operation here because this 3's left is matching with this 3's right and here this 3's right is matching with this 3's left. Okay, so there is one flip operation but they are same. Okay, they are same, right? So here you see r1 dot right is matching with r2 dot left. Okay, so this is the, but let's say this is with flipped. Okay, when we flipped. Okay, and same way there is one more case when we didn't flip. Okay, non-flipped, let's say non-flipped. So in non-flipped what I will do, in non-flipped I will just compare my r1 dot left with r2 dot left, r2 dot left and my r1 dot, here I am comparing r1 dot right with r2 dot right. Okay, so two things that we have to compare right here. If my this left is matching with this left and this right is matching with this right, or this left is matching with this right and this right is matching with this left. Okay, so these are the two things that I'm checking. One, let's say this variable is non-flipped, boolean type non-flipped, boolean type flipped. Okay, and in the end if any of these two are true then we have to return true. Okay, so here simple OR operation between them. Okay, so here what I'm doing, okay, so here we have to check for flip equivalence. Okay, check for flip equivalence, right? And here I'm saying one case is non-flipped. Okay, non-flipped, so non-flipped simply means that left is matching with left, left with left and right is matching with right. Okay, right is right, you can say right like this. Okay, and second case is flipped. Okay, flipped case simply means that my left is matching with the right, left with the right and right with left. Okay, so these two things that we have to check. Okay, so here what I'm doing, I'm creating one boolean non-flipped, let's say, and I'm going to write one boolean flipped. Okay, so here in non-flipped I'm just going to call this flip equivalent method. Okay, and how I'm comparing, in this flip equivalent I am passing first, this is non-flipped, so here what I mean to say by non-flipped. Okay, so here that simply means root 1 dot left is matching with root 2 dot left. Okay, so if this is true, okay, if this is true, then we have to check one more condition now. That is if root 1 dot right should also match with my root 2 dot right. Okay, so this is one thing that we are comparing. Okay, now same way here, our root 1 dot left it should match with root 2 dot right. Okay, this could be the case in case of flipped, right? Then here I am passing the right. Okay, and if this is the case, then one more thing that we need to check, that is nothing but root 1 dot right should match with root 2 dot left. Okay, so these two things that we need to check, right? Here root 1 dot right should match with root 2 dot left only. Okay, so yeah, so in the end, if any of these two is true, then return true. Okay, so here return no flipped or flipped, that's it. Okay, so now let's run the code and see if there are any code issues. So here spelling mistake, I think, right? So here I is missing. Let's run it again. So let's submit it. So see, our solution is accepted, right? So simple recursion we are calling, right? So see, our solution is accepted, right? And time complexity is going to be O of n. So I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.